Yeah, g'day guys, Nutty Professor here. Put a video on YouTube a couple of years ago about the steam bike that I built, and it's prompted a few questions from people out there, and most people were inquiring into how it was built and what it runs on and all that sort of stuff. So I thought I'd do a follow-up video on how it was actually built. I'm not an engineer by any stretch of the imagination. I'm just a bloke mucking around in his shed and having a bit of fun along the way. I've done a few restoration projects in the past. This is a 1916 Smith wheel, and quite a good little project, you know, kept me occupied for a while, but I was after something with a bit more of a challenge to it, so that's when I decided I'd build something from scratch. I like the old, the bikes around the turn of the century, the quirky nature of all the different ideas, all working out what the actual mainstream motorcycle was supposed to be really interests me. So I decided that I'd bring a bit of it back to life, and hope you enjoy the video of how I built it. This is the bike that I replicated. It's a 1896 Roper steam bike. It's a steam unit put into a Columbia Model 32 push bike by Sylvester Roper. He was an American fella who did a fair bit with steam, and he tried to get the bike off the ground and running, but the French company Didion Bouton had invented the internal combustion engine in a small scale that they could put into things like bikes and stuff, so they didn't, the steam unit was basically big and clunky and was basically, you know, obsolete before it started, really, due to the internal combustion engine being invented at roughly the same time. So bit of a shame, but let's see if we can have a bit of a crack at it anyway. In order to start the build, I needed to have some hard measurements on the bike, and all I had was photos off the internet. So after researching the Columbia Model 32, I was able to establish that it had 28-inch wheels. So using a 28-inch outside diameter from the wheels, I was able to, off the photos, construct a bit of a full-size sketch of what the bike was. So by using the measurement of the wheel, I could then transfer that onto paper of what the wheelbase would have been, and then from there I've measured angles and made triangles and stuff, so I could measure, say, from the front axle to the point of the frame up here, from the rear axle up to a mark on the centre of the head stem, and basically triangulate the bike into some sort of life-size scale drawing. So I could get the angle of the head stem correct, and then therefore work out the trail angle and all that from there. So with this particular build, I use a different boiler to what the original has, because that's a square boiler, and I'm not a boiler maker by any means. So I've come up with a round shell vertical tube boiler. So I had to do a bit of nutting out to work out how to actually make that fit in the frame at the height that it's supposed to be at in respect to the original. In order to keep thinking in a three-dimensional sort of thought process, this area here is a bit of a concern, because there's a lot of moving parts, and therefore clearances need to be accounted for in a three-dimensional way. So I made an overhead sketch of the the main working area of the bike, as in all the moving parts and all that sort of thing. So this is the actual boiler shell here from overhead. These are the twin frame spars coming down, and this is the rear axle centre line here. All the crankshaft unit is bolted directly to the rear axle, and all the steam unit parts are in this area here, and they're connected to the boiler. So by thinking in a three-dimensional thought process, you eliminate parts clashing. Thought I'd start with the more complicated area of the build. I figure if you can accomplish those areas, the rest of it sort of falls into place after that. I know nothing about steam whatsoever, really, and researching through the internet gave me a bit of knowledge, but it was when I got a model builder's handbook was when I started to put things together. It's a double acting piston slide valve engine. It's 50 mil bore and 100 mil stroke. The problem with building this type of engine is you can buy a lot of kits and stuff online or whatever, but there's not really any plans to actually build the engine from scratch. So the valve timing presented a bit of a mystery for me there. So with my knowledge of petrol engines, I basically figured out the timing of the valving and where it should go from there. Once I had the power unit under control, I turned my efforts on making the frame parts. So I didn't have forging, so I spun up all the fittings and stuff on the lathe and brazed them all together. Made up a pretty crude jig to hold the frame all together in a straight center line alignment, and then proceeded to weld it all together using both bit of weld and a lot of braze to marry all the parts together. The boiler is a vertical tube coal-fired boiler. It has 59 copper tubes expanded into 10mm end plates in a 7mm shell. I had to come up with a way of expanding the tubes in, so I did a bit of research and saw that there were pipe expanders that actually press the copper in against the end plates. So I made a little video here just to show you how that process happens. It's on a tapered slide here, and the little rollers in the middle there expand in and out as the centerpiece goes in. I've got a copper tube here, and washers like a representation of the end plate. So the tubes fit into the end plate like so, and then assemble my little tool with the rollers in it on the tapered mandrel, and then that's put down the tube, and then you connect a drill to the other end of the mandrel, and when it turns, it winds those rollers in and actually squashes that copper in against the end plate quite hard, so you can't hammer it out or anything. So it's quite a really good seal. Once all the tubes are in, I was able to hydraulic pressure test the unit to double the operating pressure, which is 150 psi, so over 300 in the hydraulic test, and no leaks anywhere, so we're all good to go. There's just a pic of it mounted in the bike with all the various piping and stuff getting connected to it, and the insulation put on it there, so we're getting ready. I fashioned up a roller to make the rims. This is a Westwood style rim. It has hollow beads in that one, and for this build I decided to use wire in the beads and then give the bike a lot more strength, at least in the wheel area. And here's a bit of a video of the rollers at work. Put a Colorbond fence post in one end and get a rim out the other. The handlebars have quite nice, graceful, flowing bends on them, and I couldn't find any other handlebars that were even close to what I wanted, so I ended up making up this set of rollers, and you can see here I'm just testing with bits of pipe to get the right bend that I was chasing. So I made a bit of a diagram for the bend that I required, and then just kept adjusting the rollers until I got the correct bend angle. So I'm a bit open here. Go back to the rollers and make an adjustment, and then rebend it, and then bang, we're spot on. As you can see, there's plenty of challenges to making a bike from scratch. The seat here is just a flat piece of leather, wet down and moulded into the shape, but with a wooden mould to hold it there for a couple of days to cure, and then make all the hardware underneath to connect to the seat post.
First test successful.
I decided to make the bike a little bit prettier than the original because the bike's more of a functioning showpiece rather than actual utilitarian, hard-working sort of machine. So I paid a fair bit of attention into making it pleasing to the eye, and it's basically a showpiece in our house. So the only parts that I actually bought for the bike were the tyres, tubes and spokes. The rest of the pieces have been scrounged from here or there, or made completely from scratch, or remanufactured other components. So there's a fair bit of time and effort gone into it, probably about 1,000 hours in total for the whole package to go from go to woe. It takes about 45 minutes for it to steam up, and that's good for about maybe 3 or 4 kilometres, and it'll do a top speed of about probably 50 kilometres an hour. But the brakes are terrible. It really doesn't have good brakes at all. They didn't really design the brakes back then for things to stop well, so when you want to stop, you've got to think well ahead.
Thanks for watching, guys. Hope that was a bit informative and fun for you. My next project is a
1912 Indian board track racer. This is as far as I've got with it so far. I've cast all these cases myself and machined all these parts up, so I'll put together a bit of a video on this one if you guys are interested. Keep on machining.